Greetings and welcome to today's Power Hour. The topic we're going to discuss today is diesel emissions. We're going to be talking about on the engine emission components such as EGR. We're also going to be talking about diesel exhaust fluid, DEF, some of the exhaust components, even DEF injectors, pumps, DOC, the oxidation catalyst, the diesel particulate filter, and some of the sensors that monitor them. I'm going to give you a couple tips here. We're going to talk primarily about the post-repair procedures that are required through your scan tool. I'm going to give you some great tips here. This is a segment of a full evening class here, so we hope that you'll have the opportunity to sit in on that class at a later date. But we've also got a lot of these tips available on our YouTube channel as well. So, that being said, let's get started. One of the questions that comes up with this topic quite frequently is, why do we have this? What's the purpose of this? Well, it's all about clean air. And so we've got the Environmental Protection Agency looking out for all of us here. And yes, we do want to be environmentally conscious and friendly here and help improve the environment. And so the EPA has set out a different series of mandates or requirements for the vehicle manufacturers to meet when they produce a new vehicle. Now those regulations have changed throughout the years. So up until about 2007, there was one set of rules. And then after 2011, another set of rules. So if we look at what the EPA put out, it's an eye chart, right? There's a lot of information here. I don't intend for you to read all that stuff, but it's different vehicles in different categories in different specifications in which they have to meet. And so we as technicians don't necessarily have to worry about all those specifications. We just need to make sure that the check engine light is off and that the vehicle is performing as intended by the original manufacturer. So one thing when it comes to diesel after treatment or diesel exhaust compliance, for many years a lot of shops says, you know what, let's get rid of that. And customers as well said, let's delete my truck. I don't want that emission stuff robbing horsepower. Fact of the matter is, there's a lot of well-performing vehicles out there. You know, a lot of these vehicles come with up to 1,000 foot-pounds of torque right from the factory. And so they perform quite well with all these emissions components on it. Over the last couple of years, a lot of the EPA has started to crack down on shops that are doing these deletes and actually making illegal changes on behalf of their customer. There's been a lot of headlines here, such as the one you see from my home state of Michigan, where they've cracked down on numerous shops. And I can actually tell you the names and some of the people I've met throughout the years as a technician myself or shop owners. I can tell you the names of people that have gotten in significant trouble from this. And so that's really got a lot of attention in the media, but also throughout the whole aftermarket or the repair world of, you know what, we need to stop deleting these things. We need to fix them the way they're intended to be. And again, help out the environment. So here's some of those initial standards that initially came out. So around 2001 to 2006, the EPA said, here's a list of what we want to clean up coming out of the exhaust. So they focused primarily on hydrocarbons, nitrogen dioxide, and carbon monoxide. So how do they meet those regulations and standards? Well, one of the first components here was exhaust gas recirculation. So not only do we have an EGR valve, but we've also saw the influence in the onset of EGR coolers, helping to cool that exhaust gas before it went back into the combustion chamber here. And so that was really enough to meet the early regulations and standard there. We've been dealing with EGR valves for many years on the gasoline side, but it was relatively new on the diesel side. So in order to get proper exhaust gas flow, we saw additional pieces such as electronic throttle bodies being added to diesels. Now in a gas vehicle, that's used to throttle the engine. It's primarily closed, it's open up to accelerate the vehicle. In the diesel world, however, it's just the opposite. It's gonna be open, we want this thing to breathe at all times, but by closing that thing up to 5 to 15 degrees, it would create enough pressure differential to help any exhaust gases flow through the EGR valve there. And so that's what we saw with the early onset of diesel emissions. And it came with some new service opportunities. I'm sure many of you familiar with the diesel world are familiar with restrictions and internal leaks that may have occurred within various EGR coolers. So that's a great service opportunity that we saw here in the aftermarket. So along that time, we also saw the onset of catalysts. So we've been dealing with catalytic converters for many years on the gasoline side, but now we've got diesel catalysts. These early ones were not monitored. They're bolted on the vehicle, but if you look at it, there's not an upstream or downstream sensor like we saw previously. And so how are these monitored? They're not monitored in the early applications. Later model years, we're going to see multiple ways of monitoring them. Well, around 2007 model year for various manufacturers, some may have been later, some might be a little bit earlier, but a good general rule of thumb here is around the 2007 time frame. Now the EPA said, okay, we've got those three gases somewhat contained. Now we need you to monitor and contain particulate matter. Well, that gives the onset of the diesel particulate filter, DPF as it might also be referred to. And so the DPF is going to trap that and gather up any of the soot, no more rolling coal, if you will, and it's going to capture that, and then through a regen process, it's going to burn that out, and again, emit that out the tailpipe. And so we're reducing that particulate matter on these stages. Then, come 2011, all those mandates got a little bit tighter, and so they said, you know, we've got the general rule here, now we need to get a little bit cleaner with all of these. We can do a better job. And the manufacturers have. And again, we as the aftermarket service providers need to be ready to service these vehicles. They continue to get tighter and tighter. Here's one example of a modern truck. This 2023 Ram 2500 with a Cummins engine in it. We've got over 130 diagnostic trouble codes that could be set for the diesel emissions system here. And so that tells us they're monitoring a lot of different things. In order for those trouble codes to be set, that means each of those has a specific monitor that's being run. And so this is big business. This is definitely serious. So this is stuff we need to understand how to repair and replace effectively. One of the big things that we're going to be doing here when you're working on these is utilizing your scan tool. Now I want you to look in the reset procedures or the hot functions or the special outputs. There's a lot of diesel related outputs and resets that have to be done afterwards. I've got a 2012 Ford PowerStroke in the studio here with me today. We're going to go live on that. I'm going to pull up the menu on the scan tool. We're going to scroll through that. And here in a couple seconds, I'm also going to share just a couple additional examples from different vehicles I've worked on over the last couple years in which resets or relearns were required after the repair had been made. This is one of the areas which we hear from our tech line all the time. As you read on internet forums, this is a step that a lot of technicians skip over. They may have replaced the correct component, but if you don't do the relearns properly, the job's not going to be done. The truck still might be in limp-in mode or unable to pass any local emissions tests. So we need to look through our scan tool and determine which resets are available or required on the particular truck. So with a lot of new components comes a lot of new acronyms, not only on the component side, but also on the vehicle or service information side. And so here's a list of some of the gases that are going to be used or monitored in some of the acronyms. So first off, we've got CO, which stands for carbon monoxide. CO2 stands for carbon dioxide. HC is hydrocarbons. NO is nitric oxides. NO2 is nitrogen dioxide. NOx, nitrogen oxides. And PM will stand for particulate matter. Now it comes to the component side here, EGR, exhaust gas recirculation. DEF stands for diesel exhaust fluid. DOC stands for diesel oxidation catalyst. DPF is for the diesel particulate filter. NAC is for the NOx adsorbing. Notice there's a D, not a B, because this is going to adsorb it rather than absorb it. Adsorbing means it adheres to the outer surface of the catalyst components, and then they can be released. Whereas absorbing with a B means it's going to suck it in kind of like a sponge and hold it. So that's important to know the difference here. This is a NOx adsorbing catalyst. Then SCR stands for selective catalyst reduction. So as technicians, we have to have a set diagnostic process that we're going to follow as we work on these things. So let's kind of work through this here and talk our way through. And this is a procedure that I'm going to recommend you follow every time you work on one of these vehicles. So obviously the reason the customer is going to bring it into the shop is because the check engine light's on. There's some type of emissions fault and the module recognizes that, so most likely the check engine light will be on. So we want to perform a vehicle pre-scan. Scan all the modules, see what type of diagnostic trouble codes have been set in the modules, and we want to obviously record them. Now we're going to drive the vehicle to verify or duplicate the customer concerns. Again, if it's something as simple as a check engine light being on, well, that's pretty straightforward. Now we always want to consult service information and TSBs. I've talked to way too many technicians who have gone on a wild goose chase, chasing down a specific DTC without understanding how it's monitored, what components are being used to monitor, and what conditions it's being monitored under when it actually sets this particular trouble code. Many times by looking up technical service bulletins or preliminary information, PIs from different manufacturers, quite often that's gonna give the technician insight to a factory fix. This might be a common problem that they've got a solution for already. Some cases it might be as straightforward as doing a software recalibration or update there. It's gonna tell you how to do the test and which components to replace. So always consult service information and TSBs before jumping onto the vehicle. Now we want to view and record scan data. If we're taking a vehicle for a test drive, it's always important to be recording the data. It's hard enough, and in many cases it's illegal to be driving and monitoring the scan data while we're going down the road here. So it's a good idea to record it. It gives you the opportunity to analyze it when you get back to the shop and sit at the comfort of your desk and analyze what you're seeing there. Might be using a lab scope or a meter to pinpoint down to a specific component here. And we really want to get down to the root cause of the failure at this point. Now we come up to the point where it's time to replace some components. We want to do the repair. Again, follow procedures, make sure we're using torque specs, we're using the right fluids, right procedures to be done on this job. And then this is a very important piece here, and this is what I was alluding to earlier with the scan tools. We want to do complete post-repair calibrations and tests. And so this is where you're going to be going in your scan tool and looking at some of these functions here. Hopefully you're going to be guided there by looking at service information though. So here's an example on a 2012 Chevy Silverado in which I was personally called out to a shop to help complete a repair here. The technician replaced some components, including the DEF pump, which I believe was the correct diagnosis. However, the warning message was still on the dash, the truck was still in limp-in mode, and he was unable to give it back to the customer in that condition. And so by going through the scan tool here, we can see that there's a reductant system malfunction warning service bay test. And so we had to perform that procedure, which ran the DEF system through its paces, including priming the pump and then opening the injector and monitoring to make sure it was working properly. And then we also had to do a reductant fluent tank level reset. By performing these two procedures, the message went away, trouble codes were cleared, and the vehicle was successfully returned back to the customer. Here's another example of a Ford PowerStroke in which the DOC, the oxidation catalyst, was replaced here. And so at that point, we have to go in and reset the catalyst data. Without this, the vehicle still thinks it's that old used up catalyst on the vehicle, and it's gonna run through the paces as such. When we tell them it's got a brand new one on it, now the system's gonna operate and it's gonna monitor significantly different than it did before. Here's another example on a PowerStroke where the DEF pump was replaced. So we have to reset the oxidation catalyst data. Again, we wanna say we've got something fresh in here, and then we're going to clear out the old data and run it again. How did I come up with this? Well, again, by looking at service information when we were all done with the repairs. Now, from different year makes and models, different requirements are made. So as with anything in the vehicle, don't assume because you did it on a 1 year vehicle that it's gonna be the exact same on a different year vehicle. So here's one example on a Duramax. After the NOx downstream sensor has been replaced, we have to go into module setup. Now that's a different screen than output test. And so we go into module setup options here. We find the test, we reset it, and now the PCM understands that the sensor has been replaced, and it's going to clear out the message and allow the vehicle to operate properly. Now on just 1 year different here, same sensor's been replaced. Now the service procedure is going to tell us to go through the reductant fluid quality test. And we have to run this particular test. So on one vehicle, we have to do a module update. On this particular one, we're going to do reductant fluid quality tests. And it's actually going to run through the DEF fluid, and it's going to tell us if it's working or not here. So always pay attention to service information. So that being said, let's go over to the truck we've got in the studio here. I've got a scan tool plugged in. Let's take a look at this 2012 Ford PowerStroke with a 6.7 liter, and we're going to take a look at some of the service bay tests that we could do here. So I just sidestepped over here. We've got the truck in the studio. We've got an Autel scan tool hooked up, and again, there's different scan tools that have different availabilities, different functions built into them. Sometimes you might want the factory scan tool. Sometimes a different aftermarket tool is going to have different features and functions built into it than another one. I'm not endorsing one or the other, but this is what we have plugged into this truck here today. So let's go ahead and take a look at the tool. I've already got it, the truck keyed up, and I've identified the vehicle here. So if we take a look at the screen, you can see we've got a couple different options here. So first off is hot functions. So I'm going to select hot functions, and now it pulls up various things that we can do here. Well, you'll notice one of the top options here is after treatment. So if I select that, you can see we've got a ton of different options here. And so some of it, such as SCR, system emptying, I know for a fact that if we need to do some work on this SCR system, and if you're familiar with many of these things, they're located underneath the truck, and quite often the pump's mounted from the bottom up, and so it makes a mess. It's nice if you can actually pump it out. That is, if the pump is actually working. In my luck, it comes in with a full tank, the pump's not working, and we're gonna get wet. But in this case here, we can actually use a scan tool to pump that system dry, and it makes it a much cleaner job for working on it here. But if we've gone ahead and replaced the DPF, for example, if we look in the lower left corner here, I can click on that. Now it tells us that resetting the DPF parameters will clear all learned parameters that the PCM has stored for the DPF system. Do you want to continue? We didn't do that on this truck, so I'm going to exit out and just say no here. So we should be able to back out. Same thing, if we don't want to regen, if we're performing a different test, we're doing some driving here, I can suspend that. If we look in the very middle of the screen here, we see the SCR dosing measurement test. So there's specific tests that can be done here. And so, as you see on the screen, it says this procedure is used to evaluate the SCR reductant dosing capability. It will command a desired reductant dosing quantity to be injected and captured in a measuring vessel. And so this is one of those tests that service information is going to tell you to grab a graduated measuring beaker, and we're going to be able to flow a specified amount of DEF using this test here. I don't want to actually do that here, but hopefully you get a little bit of a understanding of some of the different stuff here. We've got a visual leak check, which will pressurize the system, help us look underneath the truck to see if there's any leaks. Also, if we suspect that we've got a restricted injector, which is very common on a lot of these trucks, it's going to give us the opportunity to run a cleaning test here. If I back out of the hot tests here, so if I back up a few more screens, and so I can just simply go into service. There's more than one way to enter into some of these tests here. And so I'm going to select powertrain. Now it gives me a lot of different options here. So I can go into different modes here, look at different tests, different data PIDs. But if I click on service functions, now it's going to give me a lot of those same tests here all over again. So once more, there's more than one way to access the same tests here, but it's very important to make sure that you look at service information to make sure that you are doing this specific test. So as mentioned, it's important to always be referring to service information. Here's just one example of a 2020 Dodge Ram truck in which the DEF pump assembly was replaced recently. So if we zoom in on some of the later steps here, it's going to tell us using the scan tool, perform the DEF reductant doser prime override test to its completion 2 times. Then we want to start the engine and test drive the vehicle for at least 15 minutes. And so I throw this question out there to the audience: how many of you would do this if you didn't read it in service information and fully understand this? I'll be the first to raise my hand and say, I would not. I would probably install the component, maybe do 1 test, and turn the vehicle back to the customer. That's why it's so important on these modern diesel emission systems to fully read the repair procedure through to its completion here. We want to make sure that we do the job properly and accurately. There, I'm going to step off my soapbox and get back to our procedures here. And so once we've done our post-repair calibrations and tests, now that comes back into repair verification. Does the vehicle not do what the customer said it did when they dropped it off? Before we collect the money, we want to make sure that the vehicle is properly back in service. And once again, document, document, document. Make sure we do a vehicle post-scan, just like we did a pre-scan to start the job. We want to do a post-scan. With today's modern scan tools, we can easily export it to a printer and prove to our customer, once again, that there are, in fact, no trouble codes stored. You might want to retain this for your own service records in case the customer comes back or somebody comes knocking on your door. You can prove that the vehicle was operating properly when it left your repair facility. So, in the interest of time, I can't go through all the systems step by step here, but one component I really want to talk about is the NOx sensor here. This is relatively new. People see them installed in the exhaust on these trucks, and they think about it kind of like an O2 sensor. In some ways, it might look like it. You see kind of the thimble-shaped piece that gets threaded into the exhaust there. But you notice that this goes into its own little control module, which is going to interpret the information and send a signal back to the PCM via the CAN network here. What is the purpose of this? Well, it's going to measure NOx parts per million. That's what ppm stands for. It's going to also measure oxygen percentage, and it's going to report to us different than an oxygen sensor, but somewhat similar here. So we're going to get our readings in parts per million here. I'll show you some examples here in just a second. It's also important to know that this is cross-sensitive to ammonia. The sensor is very intelligent, but it's not that intelligent. It cannot differentiate between NOx, NOx, or ammonia, which is the main component of diesel exhaust fluid. Remember, this is installed in the exhaust. We've got DEF being injected into the exhaust, and so if there's some ammonia or the DEF fluid going through the catalyst, this sensor might interpret some of that ammonia as NOx. And so we'll talk about that here in just a second. I got a great tip to share with you on what's referred to as ammonia slip. So if we look at an example from a 2014 GM Duramax with an LML engine here, at the top we can see the engine speed and RPM. We can then see the upstream NOx sensor, and it's reporting again in parts per million. We can see 325 right where this cursor is. The downstream, which is NOx sensor 2, is reading 245. We've got the reductant injector command here. So it's going to be actually being commanded here. And then we see the vehicle speed on the bottom pin. So whereas with O2 sensors, we look for a lot of activity in the upstream and little on the downstream. On this one, they might even be mirroring each other, but we want to see less parts per million coming out of the DOC. So the downstream should be reading less than the upstream. And the greater that difference is going to be the greater the efficiency here. So we can see on, this is relatively initial startup, some acceleration going on here, probably some injection occurring. We don't have a lot of efficiency here at this point. But as we look further in the drive cycle, we move that cursor a little bit further to the right. Now we see that our upstream is 198, our downstream is at 30. So we've got a significant greater difference there. That tells us that the DOC is actually doing its job. Once this thing's woke up and alive, it's going to be a greater differential between the upstream and downstream. That's indicative of a proper operating catalyst. So one of the big questions from a lot of technicians here, how do I know if this thing is telling me the truth? And how accurate is this here? There's several different options when it comes to why this thing might be reading erroneously. First off, the sensor itself could be bad. We could always have a circuit error, maybe some excessive resistance or something, a rodent chewing on the wires causing that. Maybe we've even got a faulty ECU. But another thing, as I mentioned earlier, to be aware of is ammonia slip. Now, ammonia slip is when too much of that DEF has gone through the catalyst. And so it's bled through. It didn't get all consumed at that point there. So we need to be aware if the downstream is reading higher than the upstream, that's probably a good indicator right there that we've got too much ammonia. And so my tip to you all is to do a regen. DEF is consumed greatly and that ammonia is going to be burned off during a regen procedure. So you can either take the truck out for a test drive and force the regen, or you can move it outside of the shop, take the proper precautions and force a manual regen using the scan tool, get the heat up there, burn all that ammonia out of it, now retest the truck and compare your upstream and downstream numbers there. If they're still erroneous, now I'm going to be thinking we've probably got a faulty sensor at this point. Again, we've got a lot of different trouble codes set for these things, and so they are very pinpoint accurate. And if we've got a continued repeat NOx downstream code or even an upstream code, we follow the service procedure and the specific outline tests, well, it's going to be a good indicator that we do truly have a fault. So hopefully you learned a little bit more about all these emissions components. I got a lot of the stuff, pulled it right off our parts shelf here. We've got EGR coolers, we've got EGR valves. We've even got the NOx sensors in our line here. We've got EGT sensors, exhaust gas temp sensors. I didn't get a chance to talk about that a lot, but these do fail. On our truck here recently, we had a problem with one of these, and just like every other exhaust component, it gets seized in there. So we had to use a little bit of heat in order to get this out of the exhaust. We also have our good friend DPF sensors. You might remember these from the old 4 liters or the old Fords where we had a DPF-E sensor. I think somebody had a bunch of these left over, and so they engineered them to use to monitor the DPF in a lot of diesel trucks. And so the DPF sensor is part of our product offering, as well as the DEF injectors. Now, this is an example from a Duramax where it gets mounted to the exhaust and it's going to inject the DEF into that. We've got different ones that actually thread in, depending on the design. Or maybe you're familiar with some of the Duramax where they have, on an 8-cylinder, they've actually got a 9th injector. And this is referred to as a hydrocarbon injector. So when you're gonna initiate regen, a lot of the other manufacturers will use what's referred to as post-combustion injection. So on the exhaust stroke, they'll add a little bit of extra fuel to help light the flame in the DPF. Duramax uses this. They've got a separate 9th injector, which is going to feed diesel fuel directly into the exhaust. That's part of our product offering here as well. If you're looking for more information on this very complex topic, as mentioned, we've got several training classes out there. Talk to your parts provider and get an opportunity to sit in on one of our classes, or you can find more at our YouTube channel. Go to the Standard Brand YouTube channel, type in diesel or diesel emissions. You're gonna find a ton of different tests. Even some of them using the Ford I had here in the shop today, where we perform those service bay tests and understand how to test the DEF fluid and the injectors, et cetera. A lot of different opportunities there. And then if you're looking for more information about our parts system, what's available in our line here, you can always go to standardbrand.com. We've got product information, we've got training articles, a lot of great resources to help answer any questions you might have there. Speaking of questions, that brings us up to the end here, or near the end. So I'm gonna ask my assistant producer here in the background, Corey, have any questions come in during this time?
We actually had a couple good ones here, Ryan. The first one I see is, what are some ways of testing DEF, the fluid?
Yeah, that is a good question. You can see I've got a bottle of it here at the desk with me. Who knows how long this thing's been sitting around the training center. I definitely want to test it before we put it in our truck here. There's two popular ways of testing the fluid. First is a hydrometer. It looks kind of like those old squeeze balls and the tubes we had for testing antifreeze back in the day. Some of you might recall that. And you can actually sample it in. You'll monitor how many of the discs float in the system there. Another test is using a refractometer, and this is a much more accurate test, one I'd recommend if you don't have any equipment. I look up a DEF refractometer. You put a little drop on it, and it looks at the light spectrum and gives you a reading to determine the quality of the diesel exhaust fluid. DEF does definitely have a shelf life. As it's exposed to more UV rays or temperature, is going to certainly shorten the shelf life of that.
Very good. And then we had a couple come in around the same thing when you were talking about the NOx sensors. I'm going to consolidate it to a pretty simple question. Have you seen many NOx sensors go bad? Why are they going bad?
Yeah, so another good question. I've seen quite a few of these myself, talking to different shops. You know, on our tech advisory committee, we've got diesel specialists, and we hear what they're replacing on these things. One thing I found, though, is a lot of these codes specific for this is where I came up with that tip regarding ammonia slip. I've seen a lot of these misdiagnosed because there was too much ammonia in the DOC at the time. And so the technician erroneously replaced this. Recently, we ran into a Duramax where the DEF injector was bad. It wasn't actually injecting anything in there. And so that set a false upstream code. And so again, search for technical service bulletins, look up Identifix or Diagnostic Network. You know, look at different forums to get more information on this. So this is a common failure, but you need to be aware of false diagnosis. Any other questions?
That looks like that is about it there, Ryan.
Awesome. Well, thanks everybody for tuning in here. Appreciate your attention. Look forward to a full year schedule coming out for the next year here. If you're looking at this on our playlist, we appreciate you as well, and take advantage of all the pre-recorded sessions we have here. From all of us at Standard and at the Pro Training team, we appreciate you tuning in, and we look forward to seeing you at the next one.